All right, welcome to our review for Test 8. So on Test 8, we will cover objectives 1 through 20. So honestly, Test 7 would be the best possible review because you already taken that, gotten it back with the answer, with your answers and what's right and what's wrong. So if you haven't already, you should have taken that test and corrected your wrong answers. Make sure you've done that before we go into this test because it's literally the same objectives, 1 through 20. So going through this, we're going to kind of go back and just touch on a little bit of everything here. Question 1, what is the range of the function when the domain is -4, -3, 1? Well, we're going to remember that domain means x values, and we can write that down here. And the range means y values. So what does this question actually ask you to do? It wants you to take those values and plug them in for x and see what you get for y. So let's take f of -4, f of -3, and f of 1, and we'll see what we get. All right. So f of -4, -3, and all we're going to do is a substitution for each of those. So for -4, instead of x, I'm going to do -4 minus 2 squared plus -4 squared. And let's go ahead and solve that. And I'm going to get 36. Let's just go ahead and type that in. I'm going to get 52 as my answer here. So now the next one, the only thing that will change is that instead of -4, I'm going to write -3. So -3 minus 2 squared plus -3 squared. And I get 34. And then for the last one, instead of -3 or -4, I'm going to plug in 1. And when I go back, I get 2. So what is the range when the domain is -4, -3, 1? Well, the range, we can even write it with these little brackets, is 2, 34, 52. Alrighty. There we go. Okay. On number 2, this is still substitution, but we're asking it in a slightly different way. The only thing on these substitutions, let's remember, when I plug in 5 cube root, instead of A, I'm plugging in a number. Instead of C, I'm plugging in a number. Instead of B, I'm plugging in a number. Now, the last thing is, be careful on this. Does the cube go with the cube root, or does it go with the 5? Now, on this one, I think it's pretty clear that it's cube root. In fact, most of the time, it ends up being cube root. If you're not certain on that, make sure you ask on a test. But in this case, we can see that cube is over the root sign, not with the 5. So I think that one's a lot more clear. All right, so now when I plug in, instead of A, I'm going to do 27. Instead of C, it's -2. And instead of B, it's going to be 25. Oh, minus. And I get 34 as my solution here. Okay, here's another substitution, but again, we've asked it in a different way, where I just want you to evaluate FG of 3. So that means everywhere there's an X, here and here, I'm going to plug in a 3. So 1/3, 3 cubed, plus 4 times 3. Now, if you're not certain, make sure today you know how to put a fraction in your calculator. Alpha, y equals, enter. And that will get the 1/3, and you don't have to worry about doing that. And I get 21 as my answer. Okay, now we're going to switch gears a little bit. Now, on your test, I am not going to give you this. You will have to know that already. And what is that? Why are they giving you that here? They're saying that because this graph is a line, it is a graph, it is not points. Those points are connected by lines, that I want every value in between here, not just the 3 points. That is critical. So be very careful there. I will not give you this setup. You will have to know that this is an inequality. Now, once you realize that, yes, this is an inequality because I'm dealing with a graph, now we want the range. Well, the range is y values. And on this graph, the very smallest y value starts right here. Now, that's not quite -3, but we'll go ahead and kind of round that off unless there was a better multiple choice answer there. And the highest range is going to be 4. So the range of this function goes from -3 to 4. But because it's a graph, we have to do that as an inequality. As a side note, we've also seen this exact question, and I asked for the domain. Well, the domain goes from 3 to 5. So it would be -3 like so. And this would be the domain. This question asks for range, so we're done at range. Make sure you can do both. Hey, look at that. Now, this one, though, is points versus the inequality. And you can see, again, they've kind of set this up for you by telling you how your answer is. We're not going to do that on a test. So be prepared. Oh, this is points. That means my answer is just the x values. So on this points, the x value is 0, 1, 3, 4, 6. There's your domain. Incidentally, the range, since we should be able to do both, -1, 0, 2, and then these 2 points are both the same, so we just write it once at 5. The range is y values, and we should put a y equals there, and this should be x equals, because we are talking domain versus range. Okay, now we kind of shift gears. So we've done substitution, we've done domain and range. So I'm going to keep a little running tally here. Okay. When we solve for x, we have several different ways now we can solve for x. The one way that will always work is to plug it into your calculator and use a graph. Now, the algebraic ways will also work. But don't forget, no matter what the equation is, proportion, equation, quadratic, you can always do the left side is y1, the right side is y2, and you can find the intersection of those two sides. That always works. So if you get into a jam, that's an option available to you. Do not forget that. Make sure you leave here today being able to do that on your calculator, because it'll work for over half of your test. Now, we're going to go through the way to solve it by hand, which is, in this case, to cross multiply. So we'll do 4 times this. And then we'll do 2 times this. And now we'll solve. Subtract 6 from both sides. And subtract 12 from both sides. And divide by 2. X is -2. Don't forget, we can still use our calculator as well. Y1, Y2, and go ahead and solve it that way. Either way is fine. Okay. 7, this one will be different, because even though it says solve, there's 2 variables in here. And when I have more than one variable, this is a literal equation. And a literal equation says simply move the variables and get the variable you're looking for by itself. So we'll add x to both sides. Make that a little more clear. And then divide both sides by 2. And there it is. Because there's more than one variable, we're actually just rearranging terms. This is called a literal equation. Okay. Because we are solving for x, we could use our calculator, but because this is an inequality, it's not y1 equal to y2. So this one's probably easiest simply to solve. Distributive property. Addition property of inequality. And division property of inequality. Now, because I'm going to divide by -2, this side will become 1/2, but my inequality sign will flip around. And there's my solution. Okay, simplifying a radical means our tree. So we treat these separately. We're going to treat this part as a separate radical. So we'll deal with the 2 and the 27. And the 27 becomes 3 and 9, 3 and 3. So I can get rid of a set of 3's. And this is my 3 left over. And then the -2 root 27 is the same thing as -6 root 3. Now, with the variables, we treat a little differently. We're dividing by 2, or whatever the radical is. In Algebra 1, you're only responsible for square root of variables. So 5 divided by 2, that does not come out even. It is 2 remainder 1. So we have 2 remainder 1. 6 divided by 2 is even. It is 3 remainder 0. 7 divided by 2 does not. It is 3 remainder, whoops, that's a z though, remainder 1. So this remainder 0 here, I don't really need. And now we're going to combine everything together. I've got -6, x squared, y cubed, z cubed, 3, x, z. I don't need the ones because anything to the 1 is just that letter. And I don't need the 0 at all because anything to the 0 is just 1. Now, when you multiply radicals, you multiply the outside numbers, leave the root alone, and then you multiply the inside numbers. And then I look, does square root of 15 simplify? It does not. And there's my answer. Do not use your calculator and get a decimal. We want these in simplest form. Okay, speaking of simplest form, we've seen this question numerous times so far this year now. What we want to identify, ones that are not in simplest form. So I'm looking for ones that could be broken down more. So the easiest one to spot is right here, because x to the 6th divides by 2, and then I can cancel out. Now, when I look at the rest, 5, that does not simplify anymore. So this is in simplest form, as is the 3. Remember, the numbers on the outside, the 25, this doesn't matter. It's only what's inside the radical. So D and E are both in simplest form. Those are good to go. 20, that does break down. 20 breaks down to 4 and 5, 2 and 2, and there's a pair I can pull out. So this one can be simplified more. 42 does break down. 6 and 7, 2 and 3. The problem is none of these numbers actually come out. You don't have any pairs you can pull out. So this is in simplest form, and your answers here are A and B. Okay, 11. When we do scientific notation, we are using our calculator for this. So change your mode to scientific, and then you can type this in as is. And I get 9.06. So let's round that. Let's do scientific notation. 9.1 times 10 to the 11th. Make sure you take your calculator out of scientific mode when you're done. Okay, we've seen this several times now at this point. If I want the perimeter, I need to add up all 4 sides. So all 4 sides added up, there are 4 x's, and then the numbers 27 plus 74 plus 274. And that perimeter is that according to the problem. Now, what's the value of x? Well, we would solve that equation for x. 5224 minus 375 divided by 4. And I get a decimal, but that's okay sometimes. Like so. Okay, 14. We've done this a lot now. Doesn't seem like this has given us too many issues at this point, but we'll write it out for the sake of you all having it. I'm going to have that 4 times. So negative 2 xy, negative 2 xy. There we go. And I'm not going to forget, there is still this piece hanging out at the end of it. Now, to multiply exponents, we multiply normally the coefficients. Negative 2, like all that. So negative 2 whoops. I'm going to get 16 times another negative 3, negative 48. And now my x's, we add exponents. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4 minus 3 is to the first. There we go. I don't need to worry about negative exponents. Even though this number is negative, that doesn't matter. It's negative exponents that I would have to move to the reciprocal. Hey, 25, don't forget, we're back to a solving, and solving equation can be done. Y1 equal to Y2, find the intersection. In fact, because I've talked about that, let's go ahead and do that one like that. So let's go ahead and show you what I'm talking about. Now, my calculator won't be quite the same as yours. That's okay. But what I'm talking about is that this left side, we type in, and then the right side we type in. And when I look at the graph of this, there we go. Here's the intersection, and to get intersection, we go to calculate, intersection, and I put my cursor kind of where I want to find that intersection, so here's probably close enough, and we need to hit enter 3 times until I get intersection here. Now this tells me, I don't care about the y, but it tells me the answer that x is equal to 8, or 6, my bad. And there you go. This works for every time we say solve for x, no matter what the problem is. So make sure you are aware of this. This is great as a backup on a test to check your answers. It's great if you just kind of forget how to solve something for real, because you can always rely on this. The condition is it has to say solve for x, and it has to be an equal sign. So an inequality won't work. But this could be quadratic or it could be linear. That won't matter. Now, I did add into this problem, tell me one solution, no or infinite. Well, this one has one solution. Remember, what would infinite look on a graph? Infinite would be the same line. No solution would be 2 lines that don't touch. Okay. Now we kind of get back into quadratics. Now I'm going to pause, not the video, but before we get into this, it's important to have this with quadratics. You've got your quadratic in standard form, and I wrote this as a function, but we can remember that this could be anything up top. It could be an expression with no equal sign. It could be an equation with y equals, or it could be a function. And what can you do with this? This is called standard form. Well, you can come down here and do factored form. And factored form would be 2x plus 5, x minus 3, something like that. But we've all seen what our factors look like. Okay, we can also write solutions. But we need to remember that solutions are x-intercepts. They are also roots. They are also zeros. And really the only definition between all of these, or the real difference between all of these, is kind of in the definition. Solution solves the equation. X-intercept is where it crosses on the graph. Zeros are the value that makes this 0. And root, we're going to remember that's basically the same thing until we get to algebra 2, when in algebra 2, roots can have roots where there's no x-intercepts. But for right here, we're not worried about that. But how do I go from roots to factors? Well, they are set equal to 0. Or in our case, they're really just flipped. So here, if I have minus 3, I get positive 3 as my factor, or solution. Here, I have positive 5, but I also have 2 in front of the x, so I've got 2. Now, your job from pretty much here on out, guys, is to be able to go in any direction. And in Algebra 1, you can. You can go completely around that circle no matter what portion of this I give you. And this is what we've been working on for, the last month, really, is being able to do this circle and kind of go work our way around. So how do you do this? Well, from factored form to standard form, you multiply with a box. The other way, this is box. This way, you use your graph. And here, you kind of flip factor to solution. So we have a way to go around this circle. Why did I stop and do all this? This is by far the most important thing on the year. You need to be able to understand how to go all the way around with this. Because this question asks you this. This is factored form. I want you to write it in standard form. I want you to multiply this. Well, the only way you guys have to multiply is the box. So we could do like so. And then I'm going to get 12x squared, 6x. So my answer, and always or almost always, these two middle terms will combine. And there's our question. So I went from factored to standard form. Now, the question didn't really ask that because they took a multiple choice question and kind of tailored it, but that's what we would ask you. Okay, this is still multiplying. Now, this isn't quite quadratics because we kind of keep flipping around. This one's distributive property. So 2 times 4 is 8. 2 times 3 is 6. And 2 times negative 7, 14. There we go. Okay, right back to quadratics. Now this time, you have to remember that this binomial squared, you have to write twice. And then to multiply that, we use our box. Okay, write out my terms. There you go. Oops. Okay, right back to it. Another factor to simplest form. Again, ignore the fact that this question really isn't asking you anything because they took a multiple choice, but they want you to multiply. And these two in this case cancel out, and we're just left with 9x squared minus 16. Okay, now we're going to take a little departure because here we are doing division. But this is just a monomial. So we're okay with dividing each term by whatever the divisor is. Don't forget, if they both cancel out, it's a 1. And here, this is okay. This just becomes 1 over 2n. Okay, we saw this question on our last test. And it's circle every expression that is equal to that. So we're actually taking two different things. I'm taking, can you multiply these factors and get the quadratic? And then I'm taking, can you add two quadratics together and combine like terms? And honestly, there's no great way to do it. You have to solve all 6 of these problems. This can get a little tedious. So I'm not going to go through all of these. I'm simply going to look. This one will be equal to it. This one will not. And now my combined like terms. This one will not. This one will. This one will. This is weird. They're all on the left side. Let's just double check. This one will not. Okay. There you go. Don't forget when you do combine like terms, you subtract every single term on that left-hand side. All right. Now, we've done GCF quite a bit. Find each term. And what is the biggest possible thing that can divide into all of those terms? Well, to me, I think we've gotten pretty good at doing this. Looks to me like 3 is going to go into all of them. And then for the x's, 1x could. And how about the y's? 1y could. So my GCF here is 3xy. Okay, back here to another division. So you see we kind of keep cycling through. And in this case, I'm going to do 8x to the 7th over 4x. Negative 4x cubed over 4x. And 4x over 4x. All right. 8 divided by 4 is 2. 7 over 1 is 6. And again, don't forget, 4x divided by 4x is just 1. Make sure we are catching that. I promise you your test will have that. Oops. What happened there? Okay. All right. In this one now, we've seen this with rectangles. And again, apologize. This is meant for multiple choice. That's okay. We would want to factor this. So if I have the area of a rectangle, length times width, and I want to be able to factor this. All right, now use your choice. We go back to that chart. You need to make your decision. Do you factor by factoring with the box, or do you factor by solving and then flipping those solutions to factors? In this case, I'm going to factor with the box. So I'm going to take my box. Well, smartboard's getting a little messed up. Let's try to put it like here. There we go. All right. So 2x squared and 2. And then I need factors of 4 that add up to 5. Well, those are pretty easy because it's going to be 4 and 1. Now to actually get my factors, I do a GCF, and then I divide. 2x squared divided by 2x is x. 4x divided by 2x is 2. X divided by x is 1. And 2 divided by 2 is also 1. So my factors are that. Now, that's fine. In this case, I'm going to do by finding the x-intercepts, which is also perfectly fine. This way you have one of each, and then we'll see what side of the coin you guys land on. In this case, let's bring this back up. In order to find that, I'm going to graph and we'll take a look. Okay, now in this case, my whole parabola didn't show up. So we need to zoom out. Okay, now there's my x-intercepts. Those are my solutions. Because I'm zoomed out, I can't actually look and tell. So that's why we're going to do the intersection. And we're going to find the intersection. Remember, let's go back here. We're going to find the intersection of this graph and 0. So we're going to find the intersection of the parabola and 0. So when I do the first one, I get 2. When I do the second one, I get 12. So in this case, the solutions are 2 and 12. That means the factors are -2 and -12. Either way is fine. Okay, now we also have some other options. Like this one is difference of squares. Now in difference of squares, you take the square root of each term, and if that comes out even, you write it twice, and then stick a plus and minus sign in there. This would work by graphing. It would work by normal factoring, but you 0 in there, it'd be a little tougher. But either way, it's fine. Okay. And then this one, we would want you to factor however you choose. It's still just a simple factoring problem. Now, I think this one we'll use the graph because we haven't had an example of a little harder graph here. Whoops, don't want that. Sorry about that. So let's do the same thing. Okay, and I'm still zoomed out from my last one. So let's go to zoom standard. And we can see here, this one's right on the dot, but this one's not. So it looks to me 1, 2, 3, 4, that x equals 4 is a solution. So that means x minus 4 is a factor. But this one I can't tell. So I'm going to have to do calculate intersection. And I get 0.3 repeating. That's no good. So we need to remember that 0.3 repeating, we're going to make that repeating by typing it in, and then convert that to a fraction, and I'll get 1/3. So what were my solutions? They were 1/3 and 4. So what are my factors? They are negative and negative. Okay, last part is division, and we're going to do a quadratic divide by a linear. In this case, because you guys are in Algebra 1 and you realize that there's not going to be a remainder here. to get this, because there's no remainder, divide the first terms and divide the last terms. And there's your answer. Again, only because there is not a remainder here. Okay? And this will be the same thing. X squared divided by x is x. 24 divided by 8 is 3. And last, again, now we're going to look at this guy's factoring. Let's see. Looks like they both got a 6 out of there. So when I factor this, it would become x squared plus 4x. What is that? 12. And then we just have to decide which one has their signs right. Well, this one would be correct. Now, this one, you have to explain why. So my explanation would probably be to find the x-intercepts of this graph. Well, the x-intercepts are -6 and +2. That means to flip them, they have to be, the factors would be +6 and -2. Okay, that concludes our test. Now, the last section of this is a vocab page. Make sure you are all prepared with those definitions. You should be able to provide a definition, example, or some sort of description of each of those words. Use the back of the textbook if you need any help with those. Take a look at this, go through it a couple times, and good luck on your test.